Hi, my name is Andrea Ventola. I'm a PhD student here at the University of Michigan, and today we'll be running an in-situ field density test. You want to make sure you wear your safety glasses before testing, and I will be referencing the lab manual throughout the test. Some equipment needed to run this test is the sand cone itself, and it's currently filled with our calibrated sand. We have a base plate that the cone fits into. We have a spoon, straight edge, ruler, a couple different size bowls, and lastly we have a scale. So if you look at your procedure, the first portion is to determine the unit weight of this calibrated sand, but we're going to skip that step and instead provide you that detail before testing. Next, we're going to move on to the calibration of the cone itself. More specifically, we want to know the weight of the calibration sand needed to fill up this entire cone. And the way to do that, we'll first take this initial weight. Next, we'll make sure that the valve is closed on the cone. And then we will invert the cone into this base plate. And we're going to open the valve, releasing the calibrated sand and allowing it to fill up this cone entirely. And you can hear when the sand has stopped moving, and that's when all the sand has filled the cone. Okay, so now all the sand has stopped moving, so the cone is fully filled with the calibration sand. So we can close the valve, and we can carefully lift this up. And we'll be reweighing this with less sand in it. Now we will return this sand into the cone, and then we can move over to the field density testing. We've moved to our field location and are ready to start the test. You want to make sure that you've returned all the calibration sand into the sand cone and taking the weight of this yet again. You want to make sure you take the weights of your bowls as well before testing. So when you come to your site, you want to place your base plate in as flat and as horizontal a space as you can. Should be good. And then you want to dig a hole through the center of this base plate, and you want to make sure that the hole that you dig has as vertical size as you can make it. And then you also want to make sure that the hole is roughly 10 centimeters deep. And any material that we remove and dig out, we're going to place in our large bowl. And you want to make sure as you're digging right to the edge of the base plate. You can check how deep the hole is so far. Almost there. I think we're good. We're just gonna take a little bit more off. Just clean up the hole. Okay, and that's the hole. Now that we've created our hole, we can set the in-situ sand aside and we can move on to our sand cone. You want to make sure that the valve is closed. And then similar to what we did before, we're going to invert the cone, in the same spot. And this time when we open the valve, instead of just filling the cone, the calibration sand is going to fill in the cone as well as the hole that we dug underneath. And similar to before, we're going to close the valve as soon as we stop hearing the sand falling. Now that the sand has stopped flowing, we can close the valve. And we can slowly lift up the cone. You want to set this aside. And you're going to want to carefully salvage as much of this calibration sand as you can. And you're going to scoop this calibration sand into a smaller bowl. Now that we're back in the lab, you want to take the weight of the large bowl with the in situ sand. Then you'll want to place this in the oven to oven dry for 24 hours and then take the dry weight of this. And lastly, you want to take a weight of the cone after testing. And that concludes the in situ test.